Welcome to my video on transposition of matrices and vectors. This is the fourth video in my series on matrix mathematics. And in this video, I want to talk about transposition. It's actually a fairly simple concept compared to some of the other stuff we've seen. So we're going to take our basic matrix, A, which is index from I and J, and they run from M to N. So it's either going to be a square, rectangular matrix, just full of numbers or equations or formulas. And the transpose of it, all we're going to do is we're going to interchange the I and the J, and now it's going to become an N by M matrix. So the transpose is obtained by interchanging the rows and columns of A. So it's a fairly straightforward definition, but let's do some examples. So A is going to be equal to 1, 2, 3, 4. Now A transpose is just going to be interchange the rows and the columns. So this first row becomes the first column. That's 1, 3. The second row, 2, 4, becomes the second column. So that is our transpose. Now in this case, we started with a 2 by 2. So M and N are the same, so it still remains a 2 by 2 matrix. Now let's look at another example. Let's have B is equal to 5, 8, minus 1, 4, 0, 2. Now that is going to be a 3 by 2 matrix, 3 rows, 2 columns. B transpose, interchange rows and columns. So the first row, 5, 4, becomes the first column. The second row, 8, 0, becomes the second column. And the third row, minus 1, 2, becomes the third column. Minus 1, 2. Okay, so that is the transpose. So now the 3 by 2 became a 2 by 3. The M and N interchanged. Next, I want to look at some of the rules associated with the transposition of matrix. The first one is just the transpose of the transpose is equal to the original matrix. And just intuitively, that kind of makes sense. But let's do a simple example. This is not a proof, but it is an example that illustrates the point. So if A is equal to 1, 3, 2, 4, then A transpose, interchange our rows and columns. So the first row, 1, 2, becomes the first column. The second row, 3, 4, becomes the second column. Now if we take the transpose of that, A transpose, transpose. So over here, what we're going to get is a 1, 2 becomes 1, 2, and the second column 3, 4 becomes the second row. And so we can see that the transpose of the transpose is equal to the original matrix. So that's good. That's another rule. Now another rule we can have is that the sum of two matrices added together, transposed, is equal to the transpose of the individual sums. So let's do an example to illustrate that. First of all, let's take A, which is going to be 1, 2, 3, 4, and we're going to add it to matrix. So this is our matrix A, this is our matrix B, 4, 6, 5, 9. Now that is going to be equal to, adding these together, we're just going to do A plus B first of all. So it's A, the first elements together, that's 5. 3 plus 5 is 8. 2 plus 6 is 8. 4 plus 9 is 13. So now that is the matrices added together. Now we take the transpose of that. So the first row, 5, 8, becomes the first column. The second row, 8, 13, becomes the second column. So that is the transpose of the sum. Now let's see if that is equal to this. So let's take A transpose is just going to be the 1, 3 becomes 1, 3, the 2, 4, 2, 4, plus, I'm just over here on this B matrix now, so the 4, 5 becomes 4, 5, the first column. The second row, 6, 9, becomes the second column. So there is the transpose of that. Now let's add these together and see what they come up with. So 1 and 4 become 5. 2 and 6 become 8. 3 and 5 become 8. 4 and 9 become 13. And let's verify that this is equal. So we did not prove this result, but we did illustrate it. So that's good. Now there's a couple other rules that you want to be aware of that involve the transposition of matrices. And this has to do with a constant. That could be just a number, 3, 5, 9, or 1, 2, 3, or 141, times the matrix. And then that's all transposed. That's just equal to, you can factor that out. And we did a video on multiplying a matrix by a scalar. And so this, I'm not going to go through and illustrate this one, I just want to make sure you're aware of it. Also, we take A, B multiplied together, take the transpose. That's equal to the product of B transpose A. Notice one thing, the order has changed here. It's not AB, it's BA. So you want to take note of that. So this is a little bit more about matrix transposition. I hope you got something out of this video. If you did, give me a like, a subscribe, thumbs up, and thank you for watching.